Have you ever looked at something and thought, that's a weird pattern? Is it a real trend or is it just random coincidence? Well, there's actually a powerful statistical tool designed to answer that exact question. Today, we're going to pull back the curtain and see how simple counts can reveal these incredible hidden relationships all around us. And we're going to do it by tackling a truly profound question. When it comes to hot dog toppings, do men and women really have different tastes? Now I know it sounds a little silly, but stick with me here, because this is the perfect kind of question to show just how powerful this tool can be. So here's our game plan. We'll start with our big condiment mystery, introduce the statistical test built to solve it, and then break down exactly how it works. After that, we'll see why this whole idea matters way beyond the lunch counter. Let's get into it. All right, first things first. Before we can test anything, we need some data to work with. Okay, so imagine a food service manager collected this data. Just by glancing at the table, you can see the raw counts. It kind of looks like more women prefer ketchup and maybe more men lean towards mustard. But here is the million-dollar question. Is that difference real and significant, or is it just the kind of random noise you'd expect in any small group? To know for sure, we need a formal test. And this is where the hero of our story comes in, the tool that helps us separate a real, meaningful pattern from just random chance. It's called the chi-square test, and you'll see it written with that Greek letter chi. This is basically the go-to tool for analyzing count data like this. Its entire job is to look at variables broken down into categories, like in our case, gender and condiment choice, and then determine if the relationship between them is statistically significant or if it's all just a fluke. So, how does this thing actually work? You might be thinking it sounds super complicated, but honestly, the entire test boils down to one really simple, really powerful comparison. This slide right here, this is the heart of the entire test. On the left, you've got reality, the observed numbers from our survey. And on the right, you've got this hypothetical world, the expected numbers we would see if there were absolutely zero relationship between gender and condiment choice. The chi-square test is just a ruler. It measures the distance between what really happened and that hypothetical world. The bigger that gap, the more likely it is that you found a real relationship. So it all comes down to that one comparison. Let's stop talking theory and actually apply this idea to our hot dog data and see what happens. Okay, so let's look again. This is what we actually saw in our survey. This is our observed data. Keep these numbers in your head for a second. And now, look at the numbers in the parentheses. Those are the expected values. That's the world where condiment choice is totally random and has nothing to do with gender. You can see the gaps, right? We observed 15 men choosing ketchup, but we expected about 19. We observed 25 women choosing ketchup, but we expected closer to 21. The test's job is just to add up all of these little differences. So how do we add up those differences? Well, with this formula. Now, please don't get scared by the math. The only thing you need to know is that this formula simply goes box by box through our table, calculates that difference between what we saw and what we expected, and then it boils it all down into one single summary number. That is it. After running our condiment numbers through that whole process, this is what we get, 2.95. That single number represents the total amount of difference between our real-world data and that no relationship idea. And the rule of thumb is, the bigger this number is, the less likely it is that our result is just a random fluke. So we have our number, but what does 2.95 actually mean? Is it big enough to be a big deal, or is it small enough that, it could have just happened by chance? It's time to get the final verdict. To get that verdict, we have a little showdown between two numbers. The first is called a p-value. For our data, that value is 0.22. Now think of it this way. That means there's a 22% chance that we'd see a pattern this strong just by random luck. The second number is our significance level, which the researcher decides beforehand. Here, it's 0.10. This is our line in the sand. If the chance of it being random is below this line, we say the result is significant. So, it all comes down to this one simple question. Is our chance of random luck, which is 0.22, higher than our line in the sand, which is 0.10? And the answer is yes. Our 22% chance of a random fluke is much higher than our 10% cutoff. And what that means is that the pattern we saw just isn't surprising enough. It falls squarely into the realm of, yeah, that could have just happened by chance. The evidence isn't strong enough. And so here it is, our final verdict. Based on this data, we cannot conclude that there's a real relationship between gender and condiment choice. The small differences we saw were likely just random noise. Mystery solved. Okay, I know what you might be thinking. That seems like a lot of work for a question about hot dogs, right? But let's zoom out, because this exact same test is used to answer incredibly important questions that have a huge impact on our lives. Take medicine, for example. You can compare patients who took a new drug to patients who didn't. You categorize them by treatment and outcome, like survived or died. The chi-square test can tell you if that drug actually made a statistically significant difference. Or how about in manufacturing? You can categorize products by which shift made them and their quality, perfect, satisfactory, or defective. The chi-square test reveals if one shift is really producing different results than the others. And you see this in social sciences all the time. You could categorize people by age group and by their accident rate. This very test helps determine if there's a real statistical link between a driver's age and their likelihood of getting into an accident. At the end of the day, this simple test gives us a way to look past our gut feelings and random chance. It's a formal method for asking, is the world I see really that different from the world I'd expect by chance? So now that you know the question to ask, what hidden relationships are you going to start looking